What if time suddenly stopped? Have you ever looked at a clock and sworn, just for a split second, that the second hand froze? You blink, and it's moving again. You tell yourself it was nothing, just your eyes playing tricks on you, just your brain misfiring, just a glitch in your perception. You move on with your day. You forget about it. It was nothing. Nothing at all. But what if it wasn't nothing? What if time really did stop? Not for a blink, not for a heartbeat, not for a single, fleeting moment. What if the entire universe simply paused? Every clock ever built, every heartbeat, every planet in its orbit, every photon of light traveling across the cosmos, every thought in every mind, every electron spinning around every atom, all of it, everything, motion ceasing, change halting, all of existence suspended in a single, eternal, impossible moment. What would that look like? What would that feel like? Would you even know it happened? Would you be frozen with everything else, unaware that anything had changed, waking up hours later, thinking only a second had passed? Or would you be aware? Would you be the only one still moving, still thinking, still breathing, trapped in a world of statues? Or worse, would you be trapped in the most terrifying prison imaginable, surrounded by your family, your friends, your loved ones, all frozen, all silent, all unreachable, with no escape and no one coming to save you? Would you be alone in a stopped universe, unable to move anything, unable to change anything, unable to do anything except think and think, until your mind shattered? This is the question that has haunted philosophers and physicists for centuries. Not just the question of what time is, but the question of what would happen if it stopped. What would happen if the river of time, the flow that carries us all forward, simply ran dry? Let me take you into this nightmare. Let me take you into the universe where time stops. But we need to start with a fundamental question. What is time? On the surface, it seems so simple. Time is what clocks measure. Time is what passes when we wait. Time is what we're running out of. But the deeper you dig, the stranger it gets. For most of human history, time was thought to be absolute. It was the steady ticking of a cosmic clock, independent of everything else. It was the backdrop against which the universe played out its drama. It was the same for everyone, everywhere. That's what Isaac Newton believed. He called it absolute time, flowing at a constant rate, unaffected by anything in the universe. It was the stage on which all of physics performed. But then along came Albert Einstein, and he changed everything. He showed us that time is not absolute. It's relative. It depends on how fast you're moving and how strong the gravity is around you. The faster you move, the slower your clock ticks. The closer you are to a massive object, the slower your clock ticks. Time is not a steady river. It's a turbulent stream, speeding up and slowing down depending on where you are and what you're doing. This has been proven. We've measured it. Atomic clocks on airplanes run slightly slower than atomic clocks on the ground. Time runs slightly faster at the top of a mountain than at sea level. GPS satellites have to account for time dilation, or they'd be useless. Time is not what we thought it was. It's bendable, it's stretchable, it's squeezable. Now let's think about cosmic time. The universe itself has a history. It began with the Big Bang about 13.8 billion years ago. That's cosmic time. It's the time measured by the expansion of the universe itself. If you could somehow look at the universe from outside, that's the clock you'd use. But here's the thing. Cosmic time isn't the same everywhere either. In regions of stronger gravity, cosmic time moves slower. In regions of weaker gravity, it moves faster. It's not a universal clock. It's just another clock in a universe full of clocks. And then there's Planck time. That's the smallest possible unit of time. It's about 1043 seconds. That's a decimal point, 42 zeros, and then a 1. It's so small that it's almost impossible to comprehend. It's the time it takes for light to travel 1 Planck length, which is the smallest possible distance. Below Planck time, our understanding of physics breaks down. Time itself might not exist at that scale. It might be granular. It might be made of tiny chunks, like a movie made of frames. If time is granular, then stopping time might be as simple as stopping the frames. But that's purely theoretical. We have no evidence that time is granular. This brings us to one of the most profound concepts in physics, the arrow of time. Why does time only move forward? Why can't we remember the future? Why can't we unbreak an egg? The answer is entropy. Entropy is a measure of disorder. In any closed system, entropy always increases. Things always get more disordered. They never get more ordered. That's the second law of thermodynamics, and it's the reason time has a direction. The arrow of time points in the direction of increasing entropy. So if time stopped, entropy would stop, disorder would stop increasing. The universe would be frozen in a single state of order or disorder, never changing, never evolving. The second law of thermodynamics would simply cease to apply. But let's go even deeper. Quantum foam. At the smallest scales, time and space are not smooth. They're foamy. They're chaotic. They're constantly bubbling and fluctuating. Particles pop in and out of existence. Space-time itself is torn and repaired in an endless dance of creation and destruction. If time stopped, quantum foam would stop. The bubbles would freeze. The particles would freeze. The dance would end. The universe would be a single, static, unchanging block. And that's exactly what some physicists believe the universe actually is. This is called the block universe theory. It's the idea that all of time exists simultaneously. Past, present, and future are all equally real. They're all just different slices of a four-dimensional block. Time doesn't flow. We just experience it as flowing because our consciousness moves through the block. It's like a record player. The music is already on the record. It's not being created. It's just being played. If the block universe theory is true, then time stopping isn't a change in the universe. It's a change in our perception. It's like pausing the record player. The music is still there. It's just not being played. But there's an even stranger idea. Boltzmann brains. This is a thought experiment from thermodynamics. It suggests that in an infinite universe, random fluctuations could create a conscious brain out of nothing. A brain that exists for a moment and then disappears. A brain that has false memories of a past that never happened. A brain that thinks it's you, but is just a random fluctuation. If time stopped, Boltzmann brains couldn't exist. They require time to fluctuate into existence. Without time, there's no fluctuation. There's no chance. There's just nothing. And then there's eternal inflation. This is a theory that suggests our universe is just one bubble in an infinite sea of universes. Each bubble has its own laws of physics, its own constants, its own flow of time. If time stopped in our bubble, it would still be flowing in the others. We would be frozen, but the multiverse would keep going. It's a humbling thought. We're not the center of the universe. We're not even the center of the multiverse. We're just one bubble in an infinite sea, and our bubble might be frozen. Now let's talk about white holes. These are the theoretical opposite of black holes. While black holes pull everything in, white holes push everything out. They are time-reversed black holes. If you could somehow exist inside a white hole, time would flow backwards. The arrow of time would reverse. Entropy would decrease. Order would increase. It's a mind-bending concept. And if time stopped, white holes would freeze too. The outflow would stop. The reversal would end. They'd just be frozen sculptures of what could have been. Then there are closed time-like curves. These are solutions to Einstein's equations that allow for time travel. They're loops in space-time that let you go back and meet yourself. They are theoretical, but they are not impossible. If time stopped, closed time-like curves would break. The loops would snap. The paradoxes would resolve themselves. Time travel would become impossible. And what about the Gödel universe? This is a solution to Einstein's equations that allows for time travel everywhere. It's a rotating universe where time loops are possible. It's a strange, exotic, and deeply unsettling concept. If time stopped in a Gödel universe, the rotation would stop. The loops would break. The universe would become a static, frozen block. The Wheeler-DeWitt equation is another fascinating concept. It's the fundamental equation of quantum gravity. It describes the wave function of the universe itself. It's a deeply strange equation because it doesn't contain time. Time is absent. It's been eliminated. This suggests that time might not be fundamental. It might be an emergent property, something that arises from deeper physics. If time is emergent, then stopping time might be as simple as changing the conditions that create it. It's like turning off the heat in a pot of boiling water. The bubbles stop. The motion stops. The water becomes still. Causal sets are another approach to quantum gravity. They suggest that space-time is made of discrete events, like points on a graph. Each event is connected to others by cause and effect. Time is the order in which these events occur. If time stopped, the causal set would freeze. The events would stop. The connections would break. The graph would become a static collection of points. Time emergence is the idea that time isn't fundamental. It emerges from something deeper. Like temperature emerges from molecular motion, or like pressure emerges from gas molecules. If time is emergent, then stopping time might be possible. You just need to change the underlying condition. You need to stop the motion of the molecules that create time. It's like stopping a clock by taking out the battery. So what would that actually look like? Let's go back to our nightmare. Let's imagine that time stops, but you're aware. You're still moving. You're still thinking. You're still breathing, but nothing else is. What could you do? How would you survive? How would you cope? First, you'd need to find a way to survive without food, water, or air. If time is frozen for the rest of the universe, then the air around you is frozen too. You couldn't breathe. The oxygen molecules that would normally flow into your lungs are stuck in place. You'd suffocate unless your bubble included the air around you. Unless you could move through the frozen atmosphere like it was water, but you'd still be a ghost in a world of statues. Second, you'd need to find a way to stay sane. Solitary confinement is one of the most psychologically damaging things a person can experience, and solitary confinement in a world where everyone is frozen, where no one can respond, where no one can even acknowledge your existence, would be infinitely worse. You'd be alone, completely, totally, utterly alone. You'd have no one to talk to, no one to comfort you, no one to help you. You'd only have yourself. And eventually, the isolation would break you. And here's the really terrifying part. If time stopped in your city, but not in the rest of the world, what would happen at the boundary, at the edge of the bubble? The flow of time would be discontinuous. One side would be frozen, the other side would be flowing. The physical stresses would be unimaginable. Buildings would shear apart. The ground would tear. The boundary between frozen time and flowing time would be a zone of utter destruction. And what about the people on the boundary? What about the people who are half in the bubble and half out? If time stops in one part of their body, but not the other, what happens to them? Do they die? Do they just cease to exist? The physics of this scenario is so beyond our understanding that it's almost impossible to even guess. But let's go further. Let's ask the biggest question of all. What would it mean if time stopped forever? If the flow of time didn't just pause, but stopped permanently? If the universe simply froze and never moved again? In that scenario, the universe would be dead. Not just cold, not just dark, dead. Nothing would ever happen again. No life, no change, no motion. Just a frozen block of space-time, a static sculpture of everything that ever was, frozen in its final moment. It's the ultimate fate of the universe, according to some theories. The heat death, the big freeze, the end of all change. But here's the thing. If time stopped forever, would that be the end? Or would it be a new beginning? Because if time stopped, there would be no future, no past, just a single, eternal, unchanging now. And in that eternal now, nothing would exist. Not even thought, not even awareness. Because thought is a process in time. Awareness is a process in time. Without time, there's no process. There's no awareness. There's no thought. There's just nothing. So the real nightmare of time stopping isn't being trapped in a frozen universe. The real nightmare is that there'd be no one left to be trapped. There'd be no consciousness, no awareness, no one to witness the frozen universe. Just a universe frozen forever, utterly silent, utterly still, utterly dead. But let's pull back from the nightmare. Let's look at the science. Can time actually stop? Is there any physical mechanism that could cause time to freeze? The short answer is no, not according to our current understanding of physics. Time is a fundamental property of the universe. You can't just turn it off. You can't just stop it. It's not a switch. It's not a dial. It's woven into the very fabric of existence. However, there are some exotic scenarios where time behaves in strange ways. In a black hole, time slows down to almost zero near the event horizon. From the perspective of an outside observer, time stops at the event horizon. Things falling into a black hole appear to freeze in place, getting redder and dimmer until they vanish. That's not time stopping. That's time dilation. Time is still flowing, but it's flowing so slowly that it appears to stop. There's also the idea of time crystals. These are structures that move forever without using energy, effectively creating a kind of perpetual motion. They are not time stopping. They are time repeating. They are a loophole in the laws of thermodynamics, not a violation of time itself. So the scientific reality is that time stopping is impossible. It's a thought experiment. It's a nightmare. It's a philosophical puzzle. It's not something that could actually happen. But the thought experiment is still powerful. Because thinking about time stopping forces us to confront what time really is and what it means to us. Time is the river that carries us forward. It's the medium of change. It's the source of all motion, all life, all awareness. Without time, there's nothing. No change, no life, no awareness, just a frozen void. But time is also a prison. We can't escape it. We can't slow it down or speed it up. We can't stop it or reverse it. We're trapped in a one-way flow, moving from birth to death, from past to future, from now to never. Time is both the gift of life and the curse of death. And that's the real question. The question that's hidden behind the nightmare of time stopping. If you could stop time, would you? If you could freeze the universe in a perfect moment, would you do it? Would you choose to freeze a moment of happiness, keeping it forever? Or would you choose to keep moving forward, knowing that every moment is temporary, but also knowing that every moment is precious? The answer is different for everyone. Some people would choose to freeze time. Some people would choose to keep moving. And some people would choose something else entirely. But the choice isn't real. Time doesn't stop. It keeps flowing, whether we want it to or not. Every moment slips away, replaced by the next. We can't hold on to anything. We can't freeze anything. We can only experience it and let it go. So maybe the lesson of time stopping isn't about physics. Maybe it's about what we value. Maybe it's about how we choose to live. Maybe it's about the fleeting, precious, irreplaceable nature of existence. About the beauty of a world that never stops moving, never stops changing, never stops surprising us. About the miracle of being alive, of being aware, of being part of the river of time. Because that's what we really are, isn't it? We are part of the river. We are carried by it. We are shaped by it. We are defined by it. And we can't escape it. We can only ride it. So the next time you look at a clock, remember what it represents. It's not just a measurement of time. It's a measurement of life. Every second that passes is a second of your life. Every tick of the clock is a moment you'll never get back. And perhaps the greatest miracle in the universe isn't that time exists. It's that, for a little while, we get to exist within it.